Hi, this is Craig Lurie, and I'm the CTO and co-founder of Keeper Security. Most dev teams struggle with managing and protecting secrets. That's why we created Keeper Secrets Manager. It's a fully cloud-based, zero-knowledge platform for managing all of your infrastructure secrets, such as API keys, database passwords, cloud access keys, certificates, SSH keys, service account passwords, and any other type of confidential data. Typically, what we see happening in companies, large and small, is that secrets are distributed and stored all over the place. They're hard-coded directly into software, in plaintext config files, S3 buckets, CI/CD tools, checked into source code repos, sitting on a developer's workstation, and the list goes on and on. It gets even worse when you're handling hybrid clouds or multi-cloud environments. So you end up duplicating these secrets into separate data stores in each environment and making the attack surface larger and larger. If a secret needs to be rotated, for example, if an API key or a database password or a certificate needs updating, you risk taking down your entire production system. And you may not even know where the secrets are used. Traditionally, products like HashiCorp Vault try to solve this problem by providing you with vault servers that have to be hosted, configured with storage engines, peering, HA, and you're really just trading one problem for another set of problems. Other products in the market make you install a proxy server that has to be run in your infrastructure, which adds complexity, maintenance, and security issues. This is where Keeper shines. Keeper Secrets Manager provides an elegant and secure solution for managing your team's secrets that's built on our zero knowledge, zero trust, and cloud-based model. So in Keeper's model, all of your servers, DevOps tools, dev environments, and source code retrieve secrets from an encrypted API endpoint. The device pulls ciphertext from the endpoint, and the secrets are decrypted locally on each device. Each secret is encrypted with a 256-bit AES key, and all of the keys are wrapped by additional layers of AES and elliptic curve keys. You don't have to deal with the crypto because our SDKs handle that transparently for you. There are many benefits to using Keeper for managing your secrets. We have millions of users and thousands of enterprises that are already using our zero-knowledge platform for managing all of their passwords and confidential data. So Secrets Manager is a natural extension of the platform made for developers. Let's go through a basic example. In this example, I'll create some records, allow an app to access the records, and finally, as the app, consume the secrets. The first thing I'll do is log into the Keeper Web Vault, and I'll use my Microsoft Azure for a single sign-on. I'm using Azure because this is a pretty common use case in enterprise environments, where users can log into the Vault using any SAML 2.0 compatible identity provider. We also work with JumpCloud, Okta, Ping, Duo, and many more. After I log in, my Vault is decrypted locally on my device. In Keeper's encryption model, the Vault is encrypted and decrypted locally on the device using an elliptic curve private key, and each individual folder and record is encrypted with its own client-side generated 256-bit AES key. So you can see I have several private folders and shared folders. I'll create a new shared folder and call it Production Secrets. Then I'll grant access to this folder to my Secrets Manager team members. Adding other team members to the shared folder isn't a requirement, but in a typical environment, you'll have multiple DevOps team members that may need access. Now let's create some secrets in the folder. Click on Create New, and in this case, I'll select the type of database and call it Production MySQL Database. Let's drop one more secret into this folder. Let's add a Stripe API key. Many engineers prefer command line tools, so this time I'll do it from Keeper Commander, our CLI. For Secrets Manager use cases, we can grant applications access to certain secrets. As a best practice, the application should follow the principle of least privilege. This means that as an admin, you may be able to access everything. However, your app should only be able to access what it needs with the least required permission. Let's create a Secrets Manager application using the Secrets Manager app create command. I'll go ahead and call this Production. Let's grab the shared folder identifier using the list-sf command. You can also find the shared folder UID on the Vault interface. Next, I'll assign the application to my shared folder. Doing this carves out a portion of the vault from an encryption standpoint, so only specific devices can request access to these specific secrets. You can assign one or more devices to the same Secrets Manager application and set of secrets. If you're deploying code to a cluster or an auto-scaling group, you may want to use the same device for every instance. The Secrets Manager client add command generates a one-time access token, which we'll use in the next step when connecting a device to the Secrets Manager. I also set this up with IP lockdown, which is an additional layer of security. Okay, so just to review what we've done so far, we've created a shared folder, we've added a MySQL database password and Stripe API key to the folder. Then we shared the folder to a Secrets Manager application. And we've generated a one-time access token to hook up our devices. Now we're ready to request the secrets from one of our production machines. To demonstrate this, I'll paste a quick script into the Python shell. This script initializes the device and then lists out the secrets. As you can see, the secrets were consumed successfully. Another powerful way to retrieve secrets is through our KSM application. It can retrieve and update secrets from any shell. You can do environmental variable substitution with Keeper Secrets, which is really useful for build scripts, containers, and applications that use environmental variables for secret storage. You just replace any variable with a Keeper URL format, like this. We have SDKs available in Java, JavaScript, Python, Go, .NET, PowerShell, and more. Keeper Secrets Manager has out-of-the-box integrations with many DevOps tools, such as GitHub Actions, Jenkins, Azure DevOps, Docker, Kubernetes, Ansible, and we're adding more integrations all the time. Hopefully you have an idea of the power and simplicity of Keeper Secrets Manager. In summary, there's no hosted servers, it's full zero-knowledge encryption, and there's no on-prem infrastructure. We keep this simple for you. From here, you can jump in and get started with Secrets Manager, or check out our full enterprise platform demo available at keepersecurity.com. Also, check out our Secrets Manager documentation at docs.keeper.io/secretsmanager. Thank you.